Once again, good day, class. Let's proceed to the second distribution of air pressure that is also under the lesson 5, where we discussed earlier the first distribution of air pressure, which is horizontal distribution, right? Now, let us know what is this vertical division. But before that, I have a question for you, class, that I think most of you have an idea about this. So, what are the different layers of Earth atmosphere and how do they vary with altitude? Anyone in the class? Yes, the Earth atmosphere is divided into several layers based on how temperature changes with altitude. The lowest layer is the troposphere, where temperature generally decreases with altitude and weather events occur. Above the troposphere is the Yes, stratosphere, where temperature increases due to the presence of ozone layer which absorbs ultraviolet radiation. Beyond this, there are the mesosphere, where temperature decreases again, and the thermosphere rather, where temperature rise significantly due to the solar radiation absorption. Last is the exosphere is the outermost layer, where the atmosphere transitions into space and the air is extremely thin. Each layer has distinct characteristics that affect weather, climate, and human activities at different altitudes. So what is this vertical division? Vertical division in the context of atmospheric science thus refers to the stratification or layering of different properties of the atmosphere with altitude about the Earth's surface. This division occurs because the atmosphere is not uniform. It varies in temperature, pressure, density of gases, and other characteristics depending on altitude. This vertical division are typically categorized into layers, such as the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So, this troposphere is the lowest layer where the weather occurs. It extends from the Earth's surface up to about 8 to 15 kilometers or 5 to 9 miles, depending on latitude and season. The second one is stratosphere. Above the troposphere, the stratosphere extends up to approximately 50 kilometers or 31 miles. It contains the ozone layer, which absorbs and scatters the ultraviolet solar radiation rather. The third one is mesosphere. Beyond the stratosphere, the mesosphere reaches up to about 85 kilometers or 53 miles. Temperatures decreases with altitude in this layer. The fourth one, which is the thermosphere, above the mesosphere. The thermosphere extends to about 600 kilometers or 373 miles or more. The temperatures here can reach very high levels due to the absorption of solar radiation. The last one, which is the exosphere, this is the outermost layer where the atmosphere transitions into space. It extends from the thermosphere rather, that is outward with gas particle becoming extremely sparse. Each of these layers has distinct characteristics including temperature, gradients, pressure changes, and composition variation. Now class, this vertical division of air pressure in Earth's atmosphere is primarily influenced by the changing density of air molecules with altitude. At sea level, the densest layer of the atmosphere, air pressure is highest because of the weight of the overlying air creates greater compression. As one ascends in altitude, the air molecules encounter lower pressures and temperature, causing them to spread out and decrease in density. Now, this phenomenon explains why air pressure decreases with height. The higher you go, the fewer air molecules there are per unit volume. Importantly, while the relationship between air pressure and altitude is inversely proportional, meaning higher altitude correspond to lower pressure, the rate of pressure decrease slows down at a higher altitude. This is due to the fact that the atmosphere becomes less dense with increasing altitude, causing each incremental change in altitude to have a smaller effect on air pressure. For instance, at the peak of the Mount Everest, the air pressure is much lower than at sea level, making it difficult for climbers to breathe without supplemental oxygen. Now, this understanding of vertical air pressure distribution is essential for various applications, from aviation and meteorology to environmental science and high altitude engineering. And that's all. I hope that you understand what is this vertical division.